All right, this is going to be a very, very short video just to talk about cyclic alkanes. Once we understand the rules for cyclic alkanes, we can apply those rules to cyclic alkenes and cyclic alkynes as well. So in all of the molecules that we've learned so far, they've all been chains. So for example, I'm going to draw propane here as a condensed structure. So I've got 3 carbons, right? And each of them with the appropriate number of hydrogens. So this would be what we call a regular alkane. When we say cyclic alkane, that means that alkane, those number of carbons, are actually not a chain, but rather a cycle. So if you take a look at this here, this would be a 3-carbon cyclic alkane. So I've got each carbon having 2 hydrogens. So this is a cyclic alkane. So while this might be propane, this is cyclopropane. Okay, and that is very important when we are naming these, to include that prefix of cyclo. That implies, so if a person is looking at the name cyclopropane, our goal is if they look at an organic name, they should be able to reproduce that if they want to draw that out. If they know the rules out, they should be able to draw the exact same structure that you're talking about. So if you see a cyclic molecule, you have to include the prefix cyclo into there. So let's start by naming this as practice. So here I have a fluorine attached to this particular cycle. I'm going to start by counting the number of carbons, and there's a few ways that I can number this, right? And we learned in our previous rules that we want our side groups to have the lowest number possible. So in this case, I've got the fluorines, or the fluorine here, and I want to number this so that it has to have the lowest number possible. And if I start numbering here, I can ensure that that is the case. So 1, 2, 3, 4, 5, 6. So I see that there's 6 carbons in this cycloalkane. So I can write my parent name just like I'm used to doing. So that would be a cyclohexane. Right, 6 carbon, and there's no double or triple bonds, so I can use the ending ANE. Now in this case, I have to name the fluorine, and that is a side group. And in the alkyl halides video, we learned that if you've got a halogen, you have to add it as a fluoro or a chloro or a bromo, depending on which halogen you have. So since I've got the fluorine here, I'm gonna write it as the fluoro. So I'm just gonna add it here, fluorocyclohexane. Now I'm not going to include the 1 here, and the reason for this is very important. If I were to, and this has to do with the fact that I only have 1 side group and I only have 1 fluorine. And if that is the case, let's say I put the fluorine here on this end of this exact same cyclohexane. You'll notice that when I numbered it, I purposely put the 1 where the fluorine is attached to. So even if I put the fluorine here, when I'm numbering it, this has to be carbon number 1. So because that's the case, because I only have 1 of these side groups and it's only 1 of these fluorines, I can just write fluorocyclohexane because that 1 is implied. There's no other possibility for this particular molecule. There can never be a 2-fluorocyclohexane. That is not possible. Okay. Moving on to our next example. So here's the situation where not only do we have multiple side groups, we've got multiple of the chlorine, right? There's 2 chlorines and then 1 iodine. So in this case, we definitely have to number these. We have to put in our number in an appropriate way. And I want to start where, in a way such that my side groups have the lowest numbers possible. So because I have 2 of these chlorines attached to the same carbon, if I call this carbon number 1, both of them are going to have the 1 number. They're attached to the first carbon, right? And I like that, so I'm going to keep that there. Now my 2 options are either to go clockwise or counterclockwise. So if I go clockwise, I can do 2, 3, 4, 5. If I go counterclockwise, my iodine would be on carbon number 4, and I don't like that because right now it is 1, 1, 3. Those are the carbons that have side groups on it. If I go the other way, it would be 1, 1, 4, and that's not good. I like the 1, 1, 3, so I'm going to keep that. So my parent chain, or my parent name, is cyclopentane. So it's still a cycle. I don't see any double bonds or triple bonds, so I can just name it as an alkane. So cyclopentane it is. And I see the number. So I've got 1,1-dichloro. And I see 3-iodo. Right? So these are my side groups with the numbers. And I want to, if you remember from the previous videos, I have to compare the alphabetical letters to see which one comes first. And the di is never included in this. It has to be the first letter of whatever the side group actually is. So in this case, since this is a chlorine, the first letter is a C. And since this is an iodine, the first letter is an I. So I've got 1,1-dichloro. Oops, I'm running out of space here. I'm just going to erase that and write it again. So 1,1-dichloro is where the chlorines are located. And then I have 3-iodo to account for my iodine, and then cyclopentane. Oops, cyclopentane. And a few things to remember here. If I'm ever separating a number and a letter, there has to be a dash there. If it's just letters, so this iodo and cyclo, I don't need any space or anything between here. It's just one continuous word. So this is how you would name this particular compound. All right. And that's pretty much it for that lesson. You can do more practice, or we will do more practice in class tomorrow. We will look at some cycloalkenes and cycloalkanes, alkynes as well.